In this video, we're going to talk briefly about the different pieces of an ellipse. And so what I want you to do is I want you to notice how on the left side we have a horizontal ellipse, and right here we have a vertically oriented ellipse. And so the way you can tell, obviously, is that this one looks like it's sitting horizontally. When you're looking at the equation, the way that we know we have a horizontal oriented ellipse is that this piece right here is going to be a bigger number than this piece right here. So you'll notice in the two equations that right here we have a squared, and over here we also have a squared. The difference is, where does the a squared sit? On the left side, where we have the horizontally aligned ellipse, the a squared is under the x. And so that tells me that it's a horizontal aligning. And then here, the a squared is under the y. And so I'm having a little trouble with my pen. So here, my a squared is under the y, which tells me that it's going to be a vertically aligned ellipse. Okay, so basically then, you should be familiar with the fact that this minus h and minus k has to do with the center, hk. That should be familiar to you. Where the center, in this case, on this example ellipse, is at 0, 0. So that equation would simply look like x squared over a squared. Again, this is a horizontal aligned ellipse, so I know that the a goes under the x. And y squared over b squared. Apologize here because my pen's not functioning, so I have to use the mouse, and that is not stellar. All right, anyway, so what we have is we have a horizontally aligned ellipse. My larger number would be under the x squared. So a represents the distance from the center to the vertex. So that's a. My major axis, however, would be a in both directions from the center to each vertex. So my major axis, and maybe I should type this because it would work a whole lot better. You'll be able to see that better, I think, read my handwriting. So we have a major axis is 2 times a, and our minor axis will be 2 times b. And so pretty much then what we know is that this distance here from the center to the vertex is going to be a, and from the center to what we call the co-vertex is going to be b. And so you can see these numbers here in the horizontal aligned. We have a here, and we have b here. That was pretty. Here we have a in the vertical alignment. Had to take a peek at that. I didn't know what I was looking at. And then B here, oops, where we have the horizontal piece. That's pretty. Okay. And so these points right here, that's your vertex. This is your co-vertex, your co-V, if you will. This piece right here is called the focus, the focal points. Now, the thing is, if you don't really understand ellipses, you might think that the foci, or the focal points, are not important. But realistically, if you don't have the foci, you don't have an ellipse. Imagine, I know your mom would be really excited about this, that you took 2 nails and you hammered them into your mom's best coffee table, maybe the dining room table, I don't know. Please don't actually do this. You know, we're just saying what if. And then you took a rubber band and you stretched it to go around those 2 nails. Then you took a writing utensil of some kind, put it in between the sides of the rubber band, and stretched that out to as far as you can. And then you began to draw. What you would have is an ellipse. And so realistically, the foci are the most important pieces of the ellipse. Although a lot of times algebraically we don't really feel like that's the case. So with an ellipse, the foci are always going to be inside the ellipse, which means that this distance from the focal point to the center, which is C, should be smaller than A. So in order to actually find C, what we're going to do is we are going to say that C is the square root of A minus B. And we want to do it this way, or excuse me, A squared minus B squared. We want to do it this way so that it doesn't end up as a negative number, because remember that A is going to be a larger number. The larger number tells you what direction it goes. If A is with X, it's horizontal, and if A is with Y, it's vertical. So the way that you're going to find your focal points is that you're going to use the square root of A squared minus B squared, the larger number minus the smaller number, because we want C to be smaller than the major axis, or half of the major axis.